Hi, Heather.
Yes,
Hi, good afternoon.
good afternoon.
What time is the class supposed to start?
It's starting at 4.
Oh, okay. Sorry, I thought it has already ended.
No.
No, then thanks. I'll join in.
Okay, cool.
Hi guys. One of those days. Okay, I am here. Let's start. Can you guys see my presentation? First, can you hear me? Hi everyone. Okay, cool. Okay. Okay, so I think last week we basically looked at and I'll just quickly run through it. So last week we basically started with a differentiation. We looked at the simple way of looking at the differentiation. Then we looked at the power rule. Basically looked at some of the exponential and natural log functions. Then we looked at the chain rule. We did a few examples on the chain rule. Then we just started with a product rule. We did one or two on that. And then it was basically to say, well, today we start with the next one. So just want to get everybody on the same page. Do we need to go back to one of the previous ones? Or can we just go on with the quotient? I don't know how you guys pronounce it, quotient or quotient rule, but Must I first go back to one of the previous ones, or? Okay, please revise. Cool. Okay, so let's quickly. Okay, so let's look at the chain rule. So basically, what the chain rule did, and let's. So what the chain rule did was that you would have made, and we can erase this. So I think let's do that. So what the chain rule did was that you basically created or made that equal to something. So let's make it equal to u. Then what we basically did was to take we differentiated that u to the power of 5. So basically we differentiated that. Ooh, okay, so let's try again. Now, can you see the screen?
Yes, we can see the presentation.
Okay, cool. Okay, so basically what the rule then said is that, so now we have u5, so that we now needed to differentiate. So that will be five u to the power of 4, and then basically what we need to do is we need to multiply that by the differentiation of the internal term. So if we differentiate that, that would have been just 2. So 2x will become 2. So we know when we differentiate that, it is basically 1 minus 1. So x to the power of 0 basically becomes 1. So then we have 10u to the power of 4. And then basically we need to replace that u again. So that we will replace with the 2x plus 3. So basically from there, and that will be your answer. So that again is just to quickly look at how the chain rule works. So it's basically, and for me, the easiest to look at it is you need to substitute that term with something easy. You differentiate then that whole term. So that's the point 1 or step 1. You differentiate that whole term. And then step 2 is you differentiate the thing that was in the brackets, and you multiply it out by one another. Okay, so that's the one rule. Then our other rule that was a bit more difficult was the product rule. So what the product rule says, and again, it doesn't matter which way you do it. So let's look at this one again, and I'm gonna take that out. And what I'm also gonna do, just that we have a bit more of space to work with. Okay, so what this rule does, the product rule, is basically, and again, it doesn't matter in which sequence you're doing it. And I think that for this one is important. It doesn't matter which sequence you are doing it. So what the product rule does and says is, you take that first term, and again, let's not worry about the sequence. I will show you now. As is, and you will multiply that with a differentiation of the second term. So if we look at that, the second term was 3x plus 2. So if we differentiate that, it is basically 3. So that's step number 1. Then step number 2 is you take that second term and you multiply it by the differentiation of the first term. And that differentiation then is 2x plus 2. And then you basically add those two together. And you can see, so here they did it the other way around, but there is your 2x plus 2. There is your 3x plus 2. There is that one, and there is the 3. So it doesn't matter which way you want to remember it. For me, it's always easier. I know I take that one, the first term, I'll multiply it by the differentiation of the second one, plus take the second term, multiply it by the differentiation of the first term. But that basically, so the product rule is, in a sense, a nice one, that it doesn't matter which way you do it, as long as you just do it in any order, but you need to do both steps. Where if you look at this one, so let's look where the chain rule, also not really needing to which one is first or anything like that. You just need to know that you need to do both parts. When we get now to the new one that we're starting off today, the quotient, and if you want to call it quotient, I don't know how you pronounce it, but here it is very important that you need to do it in the correct steps. Otherwise, you will get a different answer. Okay, but before we get to that, are you guys nearly happy with just the check-in on the chain and the product rule? It was very quick that we went through that, but I just want to make sure that it is nearly... Okay, cool. So let's do that, and then let's go into the next one, the quotient rule. And let me also, I want to copy that into this so that we just have it nearly with us when we do it. in the exam you will also have all the formulas. So I think that at least is a positive, and yes, I put it there, but I just want to have it with me as we explain it as well. So when you look at this, I rather want to explain it with an example, because it's always easier to explain it with an example. Otherwise, it becomes very technical. So when you see that you're sitting with a term at the bottom that has more than one term nearly, then we need to work with a quotient rule. So if that was only a 2, then we could have divided everything, that in by 2, that in by 2, that in by 2, and it would have been fine. If it was only 3x, we could have done the same. So, but when it is nearly 2 terms, or 3 terms or more, then you need to use the quotient rule. So then there's nothing that you can nearly do to solve the answer except using the quotient rule to do the differentiation. And I think that is just important when there is, and it's only, you use this rule only when you are actually dividing by something. Okay, so otherwise you would use the product rule or the chain rule. So I think that is the other important thing. You only use it when you actually have a term that you are by something else. Okay, so basically what they always do, and we've seen it with some of the previous ones, they let the one be u, they let the other one be v. Again, you can decide what you want it to be. It doesn't need to be VE and U. It can be X, Y, it can be anything else that you are comfortable in using. Then you will look at this and see, so you get the differentiation of the one part, you multiply it by the formula of the second part, and then you basically turn that around. So very similar to what we did. What was it with a product rule? Let me just quickly check. So very much what we did with a product rule. So very much what we did with a product rule, but we're not adding, we're subtracting. So that is the one difference, is that we are subtracting. And then the other thing that we also need to see is we always then divide by, and maybe green is not good for what we are with a green background, but then we divide by the one that's at the bottom, but the square or to the power of 2 of that. So that is always the case. So that is what you need to do. So basically, again, you can decide how you want to do it. The hint that they give you here is to automatically do the differentiation of the first term and the second one, that you can just nearly automatically put it into the formula. So I actually like that way, because again, in the exam you will get the formula page, so then it is easier just to slot it in. So basically what this tells us is we need to differentiate the top one. So that would have been 2x plus 2. We will multiply that by what was the v term, and that is 3x plus 2. Just hope I've got enough space on this side. Let me quickly. Okay, so that was for 1, then minus, so we take the top one, and we multiply it by the differentiation of v, which is the bottom one, so that is just multiplied by 3. And then we need to divide it by v to the power of 2. Okay, so let's just check. So that is same, that's the same, that's the same, that's the same, that's the same. Now it's nearly your algebra maths need to kick in here. So now you need to first see if you can solve that. So 2x times 3x is 6x squared. 2x times 2 is 4x. Then 2 times 3x is 6x. And 2 times 2 is 4. Then we will multiply 3 in with each one. So I'm just going to do it automatically. To remember, there's a negative. So 3 times x to the power of 2 minus the negative. So it is 3x to the power of 2. 3 times 6x is 3 times 2x is 6x minus, so we will get that. And then 3 times 1 gives you 3, but it is then a minus. And that all divided by, now we need to make sure that we do that. So they actually didn't do that. So I think that is also nice to see that you actually don't need to go to that length to multiply that out as well. And then you need to make that simpler. So there's the 6x squared plus that one. So that gives you a 3x to the power of 2. All the x's, so 4, 10, that was minus, so it is plus 4x. And then we have plus 4 minus 3, which is plus 1. Okay, which is exactly what we get there. And that one we will just move, and that is your final answer. Okay, so this one, nearly if you understand the formula, but this one you need to follow the exact formula, because if you swap the two of this around, that will be becoming a negative values or will look different. So it is important to know the order in this calculation. Okay, but I actually like the way that they did it here, is to nearly say, but already do the two differentiations. So when you look at your formula page, you can nearly just substitute what is in the formula page. And again, I like that formula more than I like this one. It's always for me a bit more difficult to look at it this way, where I like that one a bit better. But again, sorry, I don't know. Yeah, it's probably because I've been doing this now for quite some time. But yeah, I think it is And the challenge normally is for you in the exam as well is they will probably ask you two of it, and it becomes nearly very difficult, especially between the product and the chain rule sometimes, which one to use. This one is very straightforward because if it's divided by, you need to use this. And I think that is nearly the difficulty is more in realizing what they are asking in the question, and to what extent do you need to go to get to the answer. But I think we will definitely work out one of the previous papers, and you all that now have submitted all of the assignments, and you would have seen that assignment 3 was taken from a previous exam paper. So assignment 3 is nearly the way it will be. And I think that is nearly how you need to prepare yourself for that. Okay, so let's look at this one, because it is a bit more difficult. But again, let's make it easier for ourselves. So we know that this is the formula that we will work with. So let's make it easier for ourselves. So that is your one term, that is U. That will be V. So just remember that. So when we do the differentiation of that one, that is easy because that is just going to be 2x. When we do the differentiation of this, it's more difficult. And I nearly need to rephrase it, more difficult in the sense that they try to catch you out. So we know that the differentiation of EX is EX. Okay, so now they throw in the 1. Okay, so what is the when we differentiate 1, it actually becomes 0, so it will fall away. So the bottom term differentiated is EX. And I think that is, so when you originally looked at this, it does seem difficult, but actually then it is not that difficult, because when you differentiate it out, you can see it is actually not that difficult. But I think the important thing is one is always worried what happens to that 1. But the same, if it was at the top, that again you would have done exactly the same and said, well, that's going to be 2x, that is going to be 0 because that will fall away. So just because it's now e to the power of x, don't think you must treat it differently. The ex you treat differently, but not everything. That still stays the same. Okay, and then we can just follow the rules. So what was the differentiation of the top one? It was 2x. What was the term at the bottom? It was 1 plus e to the power of x. Then we need to remember it's minus. So what was the first, or the u term? It was x to the power of 2. And what was the differentiated part at the bottom? E to the power of x. And then that whole thing we must divide by 1 plus EX to the power of 2. Okay. And then at the top, you can just multiply in. So again, don't be scared of what that there's now the EX. So you just normally multiply it in. So 2x times 1 is 2x. 2x to the power or times. So that will give you 2x e to the power of x. I don't understand why that is happening. So there is a mistake. So there should have been x, because you would see where it is in any case, and that minus must actually be in between and not there at the top. So the minus should actually be there in between, because it is that minus that is sitting there. So it is x to the power of 2 e to the power of x, and that we will divide by the 1 plus ex to the power of 2. So now all that they did was to say, okay, there we've got a x, there we've got a x, there we've got a x. So we will take x out because it is common in all of them, and only common and what is at the top. So that part will be still written there. So what's left in that one, if we take out the x, is a 2. What's left in that one, when we take out the x, it is 2e to the power of x. And what's left here, if we take out x, is basically 1x is left with e to the power of x. And then you will see that will be the same. Okay, so I think what's important with this one is, again, when you see e to the power of x, just remember how you differentiate that. And then when it is in this form, just remember the normal algebra, you just multiply out. Don't be afraid when you look at it to see, okay, now I don't know what I need to do, because it's not something that I'm familiar with. Okay, are you guys happy with that? Let's quickly get a sense check. Okay, does it make a bit more sense than when we started off this afternoon? Okay. Okay, so I nearly want to so we just now need to check. I'm gonna save this, that we can get into the next part of the differentiation. So just tell me, can you still see the screen or the presentation, or must I share it again?
Please share it again.
Okay, cool. So I was wondering if that will happen. So let's do that. And just shout when you do see it again.
Okay, I've got it.
Okay, awesome. Okay, so basically we're just going to continue, but if there is anybody new on the group, I didn't say this when we started off, but we have a WhatsApp group, so you can give me a WhatsApp afterwards and I'll add you to the group. I also will post when some of these again back onto a WhatsApp group, and we are discussing things on there, and we will probably discussing more as it gets closer to the exam. So if you're not on the WhatsApp group yet, just send me a WhatsApp afterwards or even now. And I'll later at the end, I will come back to my email or my WhatsApp, my details as well. Okay, so I thought there's still out of a differentiation nearly one or two things that we need to cover before we also get into the part that tells us a bit more of the application. So, and I think what this is nearly telling us, so when we, and I'm going to draw a bit. So when it was the x squared, say minus 4, that would have been a parabola that looked like that. When we differentiated that, it would have been something like 2x. Okay, and that 2x then would have been a line that would somewhere touch and probably at the turning point would go through that line. So when we now start working with something that is a bit more difficult, that it is x to the power of 3, it will have 2 turning points. And you can nearly look at it as when you differentiate, and whatever is with the x, that is how many turning points there will be. So when we differentiate that, it will be 3x to the power of 2. So that 2 means that we will work with 2 turning points. Okay. And again, how that will now be solved is when we factorize that out, you will normally sit with something like, and the one will be that turning point and the other one will be the other turning point. So I just think that is nearly important, is that that is how we will need to look at it. Then the other thing that it is important is that you will see here, and I don't think that they sometimes do it, but those 3 points, so that is when the x3 or x to the power of 3 equals 0, and we solve it, then you will get those 3 points. I don't think they ask that a lot, but we'll see if there is anything like that. But once again, for those calculations, they also give you some formulas, and let me just show you the one formula. Just want to check that I know I must have it in here. Ooh, I haven't, so I must bring it back. I just want to quickly go through this just to check. Okay, no, so I need to include 2 very important formulas here. So I just want to check, why isn't it in here? Okay, so I will bring that in here and then send it to you as well. So the formulas that I am referring to is the one, and let me go to my notes, because I definitely don't remember that, is, okay, where is it in my notes? Oh, it was way up in front. So we probably, that one I think that it somewhere in between. It was in that one. So basically, it is the function of x is equal to minus b plus minus under the square root b to the power of 2 minus 4ac divided by 2a. So that is the one formula, and I'll see if we will use it here. And the other formula that we also have is where you can calculate with a turning point without solving something, that is minus b over 2a. So let's see if it comes out here, but let's first go through some of these things. So here we're talking about, so that is your formula. So that is that formula that we have there. So if you needed to differentiate that, it is straightforward as we've done with the previous work. So the 2 goes to the front, so 2 times 3 is 6, so 6x. It will be the 2 minus 1, which will just give you the 1, and in the other one, 18x just becomes 18, and the 34 will fall away. So that would have been your, basically your differentiated formula, and that differentiated formula will then be probably where it is the turning point. So let's look at it. So we normally know that that is how a straight line looks like. So let's see if I make that 0, we have 6x is minus 18, so that minus 18 would go to that side, so 18 is equal to 6x, and x will be equal to 3. Okay, so that is when y is 0, x will be equal to 3. Okay, so that is also your turning point. We could have, and let's see if I used the formula minus b over 2a. So that is the formula that is also in the book. If you used that, you would have gotten, so let's see, minus b is that, so that's interesting. So will it be minus 18? Because the b will be that. The a is looking at that one. So it's divided by 6, which will also have given you 3. Okay, so that is basically also how you could have calculated the turning point. Then how you need to then calculate what this y value is to put that 3 back into the original formula. You can't put it back into this formula because then it will just be 0. So it doesn't solve the answer you're looking for. You need to put that 3 back into the original formula. So if I ask you to calculate what is the turning point values, the x you can calculate with this method. You could have calculated it with that method. Either or, it's in a sense easy to do. We could have calculated, and let me just show you, you could have used this formula as well to calculate it. So that then would have been A, and that would have been B. So you would have, and that would have been C. So that is A, B, and C. So you could have done this. You could have differentiated and then use the x. You could have differentiated and substitute by 0, or you could have used the original formula, also just gotten the use the x that is equal to minus b over 2a. So nearly there's 3 ways of getting to that, but always do the x first, because then you need to use that x to put that x value back into the original. So then you would have then said 3 times 3 to the power of 2 minus 18 times 3 plus 34. And then according to this, it gives you 7. So your points would have been, the x would have been 3 and your y would have been 0.7. Okay, so nearly looking at the formula, you need to get that turning point. You can basically work out what is the differentiation of that curve, or you can go straight getting the minus b over 2a. When you get that, you can put it back into your original formula to get your y. Okay, happiness with that? Yes, no, still a bit fuzzy, still a bit not 100% sure. Okay, and I think the next one is we'll go straight into a more difficult one. So now it's quite interesting. So, and interesting always means difficult. So now you suddenly have, there's a turning point and there's a turning point. You can't use your original x is equal to minus b over 2a, because you can only use that for quadratic formula. So what we now need to do is we now need to nearly solve it the way we did here. So we will need to get the first differentiation. So to do that, it's still very simple. There's nothing difficult about this one, nearly to get that first step. So the 3 goes in front, so it is minus 3x to the power of 2. That one, if we differentiate that, it will be 18 to x to the power of 1, so we can just leave it out. And then the 20 over minus 24x becomes minus 24, the x falls away, and the plus 26, a constant, differentiate that, becomes 0. Okay, so now we have a formula that we can work with. What I would do from this point is, I hate working with a negative if it is in front, so I will try to simplify it. And you can see 3 goes in there, 3 goes in there, 3 goes in there. So I would just divide all the way through with 3. So if I do that, and I will actually divide by minus 3, then it is minus 3x to the power of 2 divided by minus 3 gives you x to the power of 2. Plus 18 divided by minus 3 gives me minus 6x. Minus 24 divided by minus 3 gives me plus 8. Okay, now I need to differentiate that, or factorize that rather. So if I look at this graph, it nearly feels to me it's going to be at 4. It can be a bit off. Feels to me it is at 2. So I would first try to see if I can solve it with my normal maths before I use a formula for this one. So the other thing that I just want to show you, and I don't know if you guys have done it way back in school. So in front of there's a 1, so I always say, okay, there's a 1, so 1 times 1 can give me that 1. Then I need to get to the 8. So how I get to the 8 is or 4 times 2 or 8 times 1. Okay, so if I say 1 times 4, it's 4, 1 times 2 is 2, and if I add those two, I get 6. I say 1 times 8, 1 times 1, so then I can get 7 or 9, depending if I add it up or subtract it. So I want the middle term to be 6, so then I will work with those two because that will give me 6. The middle term is negative, that term is positive, so then both terms or both signs need to be negative, because the negative times the negative will give me that positive. So it is 1x on both sides. The one is a 4 and the other one is a 2. Okay, and if you multiply that back in, you will get x squared minus 4x minus 2x, which will give you the minus 6x, and the 4 times the 2 will give you the positive 8. So now we basically need to say that is equal to 0. So x minus 4 will be equal to 0, or x minus 2 will be equal to 0. Okay, so then basically x minus 4 equal to 0, we basically then know that x is equal to 4, and that is nearly what I spotted there, and x is equal to 2, and that is what I spotted there. So then if you now need to get the turning points, you will need to put that 2 back into the original and get a value. And then if you need to get that turning point, you will need to use the 4, put it into that formula to get that y value of a turning point. Okay, so that is how you will get the 2 turning points, is to say, put 2 back into that formula, get the value of y, then put 4 back into that formula and get the value of y. Okay. So again, nearly the same principle. To get the turning points, you need to differentiate, then solve x, use x to put back into your original formula, and then you can get the y value as well. Okay, questions on that? Are you happy? Does it make sense? Please explain again if you don't mind. Okay, no problem at all, because the next one will go into, so let me rather explain it again. Okay, so so it will be in the recording in any case. The previous one that I now deleted will be in the recording. So if I don't show everything again, at least it is in the recording. Okay, so basically you need to work out the turning point there and the turning point there. To work out turning point, you will need to differentiate that original formula. So basically, to differentiate that, the answer to that differentiation is minus 3x to the power of 2, because that would have gone in front of it. 3 minus 1 gives you the 2. The 2 goes to the front, so 2 times 9 is 18. Then it is x, 2 minus 1 gives you 1. So if you want to, you can write the 1 there. And then the just also, we could have written the 1 there. Minus 1 is 0. X to the power of 0 is actually 1. So we don't need to write it. We can just basically write minus 24. The constant when we differentiate always falls away, so we don't need to worry about the 26. Then when I look at this, I hate working with a negative, so I want to get rid of that negative. And even better, if I look at the 3, 18, and 24, I can actually get rid of the minus 3. So I would then divide that whole 3 terms by minus 3. So minus 3x to the power of 2 divided by minus 3 gives you x to the power of 2. 18 divided by minus 3 gives you minus 6. And for x, I can just add. Minus 20 divided by minus 3 gives you positive 8. Okay, so that now is the formula that I have differentiated and made a bit simpler for myself to work with. We still need to solve x. So we need to solve x. You could have, and let me write that formula down. And you will get that formula, or you can actually have it. So you could have used this formula as well. The x is equal to minus b plus minus, and I hope you can see it in the green portion. B squared minus 4ac, and that whole thing divided by 2a. So you could have used that formula to calculate the 2x's as well. But when I look at this, and from my experience, when I see this, it's nice numbers. So I know to get to a 6, if I use 4 and 2, I can get to a 6. So in front of there's 1. So if I say 1 times 4, I get 4. If I say 1 times 2, I get 2. 4 times, or 4 plus 2 is 6. So then I know I am getting my middle term. So on the one side it will be 4, on the other one it will be 2. Again, just the signs, that one is negative, so there needs to be a negative at one of them. Because that is positive, this one also needs to be negative, because a negative times a negative gives you the positive. So my one term is x minus 4, my other one is x minus 2. And because we want to solve the turning points, it is where it's equal to 0. So then we can say, well, then I know that x minus 4 must be equal to 0, or the x minus 2 will be equal to 0. So then it becomes x minus 4 is equal to 0. So then you say x, and you take that to go over to that side, so it becomes a positive 4. So the same will happen there, which will give you the x equal to 2. Okay, so when you have your two x values for the turning point, then to get the y values, and that is probably not correct, you basically need to put it back into your original format or formula. So need to put 4 back in, so it will be 4 to the power of 3, and you need to put it in there and there, get the answer for y, and then we do the same for this for the 2 as well, and get an answer for y. So then you know your two turning points. Okay, that makes it a bit better to understand. Okay, cool. Any other questions, guys? Please ask. Don't mind asking questions. Okay, cool. So let's go to nearly, and this is chapter 6, but it's actually part of differentiation. And I think the important nearly thing that we need to, what we're going to do is nearly, there's a few things in this that we need to remember. So and I think what you need to remember is that we're going to differentiate the one curve to get the other one. And I think that's why we started with a differentiation, and how it's nearly, I think in your assignments, it was also the third assignment that was made it a bit difficult, is that there are questions that is purely differentiation and purely integration, but then there's questions about marginal revenue, marginal cost, marginal variable cost that you need to calculate. And actually how you calculate that is by differentiating the other formulas. So we will get a marginal revenue if you differentiate total revenue. We will get marginal cost if you differentiate total cost. You will get marginal variable cost if you differentiate variable cost. So that for me is nearly the important part out of this. And why this is also important is nearly the opposite again is happening in the integration. So when they give you a marginal revenue, you need to integrate that to get total revenue. When they give you marginal cost, you will need to integrate that to get total cost. The same with marginal variable cost. If I give that to you and want you to get variable cost, you need to integrate. So that's why this table is nearly for me important and nearly one that sums it up. If you need to go from this block to there, you differentiate. If you need to go from, and let's now take away some of this stuff. So if you then need to integrate, you basically take this block and you integrate to that side. So the one is differentiation, one is integration. And I think that is nearly, in a summary, sums up what is important. So that's why it was important for us to do differentiation first before we get here. That's why it's important to do integration before we start with the last chapter as well. But I think that is nearly a summary, and you would nearly every time see when you need to do marginal, you need to differentiate. So let's see if we can get to an example. Okay, so and what makes, and now I'm sounding like a 2020 doom prophet or something like that. But what makes it now a bit more difficult is you need to nearly remember what we did in chapter 2 and 3. So now you need to know, oh heck, what was total revenue again? How did we calculate total cost? How did we calculate fixed cost? How did we calculate variable cost? Because now that becomes important. So I think that is nearly what makes this subject so difficult. Well, not difficult, but the one follows onto another one. So you need to know now how to get to your total revenue. How do you get to your total cost and things like that? So let's look at this one. I want to see if there's, so this was basically marginal revenue. So remember, total revenue was looking at the price of that thing that you are creating times how many of them you are creating. So the price that you can sell it for times how many you are manufacturing, that was your total revenue. Okay, so it's nearly, you now need to go back to chapter 2, 3 in your mind and remember what total revenue was. So then let's see what they tell us. So suppose we have a demand function, and that is your demand function. Okay, so now remember, what was your total revenue formula? It was price times quantity. Okay, so nearly remember now that. So they give us, suppose you have a demand function, they give you the demand function. Now you need to work out what's your marginal revenue. So now it's like, oh, how do I get that? So the first thing that you need to remember is, okay, to get to marginal revenue, that will be when I differentiate my total revenue. Okay, so that is how I will get to marginal revenue. I need to differentiate total revenue. Do I have total revenue here? No, but I've got that piece, so I know that the price is that, and I have Q because that is just the number. So to work out my total revenue is I take the price, so that is your price function, and I multiply it by Q. So when I multiply that in, so 6 times Q will be 6Q, that times that will be minus 0.5 Q to the power of 2. Okay, so now I have my total revenue curve. So now the next thing that I need to do is to basically say, I've got my total revenue, now I need to differentiate that. Okay, so let's see how easy that is. So if that was 6x, it would have been just 6. So to differentiate that, that will become 6. Remember, that goes to the front, so 0.5 times 2 is 1. Then the Q2 minus 1 is 1. So your marginal revenue function is then equal to 6 minus Q. Okay, so now, and you can see that is what they have gotten as well. So that is now your marginal revenue function. Now they need to tell you something. You can't just now guess something. So they now need to tell you, but okay, if you sell 5 units, what will be your marginal revenue? So they need to tell you what that Q is. You can't, there's no ways that you now can say, but my marginal revenue is equal to 1 or 2 or 3. So if I don't tell you now what Q is, you actually can't work out the marginal revenue. Then your marginal revenue will stay as a formula. So in this example, they now said, well, okay, so let's say if you sell 5 units, what will your marginal revenue be? So then it will just be 6 minus 5, which will give you 1 rand. So what that means, and I think that is also important. Again, I don't see how they can test that with the nearly the open book exam. But what that means is for every extra unit that you are creating, you are making an additional 1 rand profit. So if you that is just basically what the marginal revenue will mean. Okay. So marginal revenue is basically, you get it from differentiating the total revenue. So when we go to marginal cost, we will differentiate total cost. The thing that makes it now bit more difficult is now we need to remember, total cost, oh yes, it is actually fixed cost plus variable cost. Okay, so we now just need to remember from that first 2 study units, what is total cost actually. But otherwise, to get to marginal cost, it is just again, we differentiate total cost. So to get to marginal cost, we differentiate total cost. Okay, so I know there's an example. So quickly before we get there, just a quick check-in. Any questions? Happy with this? And maybe let's do the marginal cost one, and then we can have a quick check-in as well. Okay, so they tell us the total cost function is that. So they tell us total cost is equal to 100 plus 40Q. Just as, again, a tip, they don't do it in this one. So, but just as a tip, remember total cost is equal to fixed cost plus variable cost. So when you have fixed cost, it will be associated with a thing that don't have a Q. When you have variable cost, depending on how many products you are making, your variable cost will go up or down. So in your total cost function, the constant is actually your fixed cost, and the one with a variable is your variable cost. Okay, so that is just if they ask you somewhere or they give you the two, that is nearly how you can also look at it. So that's just a tip from my side. So total cost, basically, if we need to get to marginal cost, it is the differentiation of that. The 100 will fall away. The Q will be 1 minus 1. So the marginal cost of this total cost function will actually just be 40. Okay, so that is it. There's no, this one was a straightforward one. There's nothing in it else than the marginal cost is 40. So let's go to the next one, which is a bit more difficult. So they give you the total cost function, and now they ask you to work out the marginal cost. So now differentiate as normal. So the 3 goes in front, so 3 times a third is 1. The Q3 will become Q2. So because there's a 1 in front, we can actually take the 1 away as well. We don't need to work with it. Minus 8 times 2 is minus 16. Q to the power of 2 will become Q. The plus 120Q will become plus 120. So that now is actually your marginal cost function. So now again, when you have that, they need to give you a bit more of information if you need to solve it. So here they say, well, when Q is 15, what is my marginal cost? And then all that you do is you replace the Q with 15 in your formula. So to get to your final marginal, you will replace the Q by the 15. So then it will be 15 to the power of 2 minus 16 times 15 plus 120, which will give you your marginal cost. So out of that, it is actually minus 15 plus 120, which will give you then marginal cost of 105. Okay, so that will then be your marginal cost. So, but once again, when here your marginal cost was only 40 because there wasn't a Q left, but when there is a Q left, they will need to tell you also, well, work out your marginal cost if Q is equal to a certain amount. Okay, so that nearly is looking at marginal revenue, marginal cost. There's the chances that they ask you what, and let's go to that. So basically the two that are actually the most important is the total revenue and marginal revenue, total cost, because that is a function of those two. Okay. So that is the two most important ones that you need to know. The other thing that I haven't spoken about is the average. So average revenue, average cost, average fixed cost. So that is nearly the next section, is to talk about that. So here again, it is in a sense simple, But again, you need to remember what we did in study unit 2 and 3. So average revenue is just your total revenue divided by Q. So again, going back to this diagram, you basically go from there to there. It's not that you are first working out your marginal revenue and then getting the average of that. So it's looking at your total revenue, and to get the average of your total revenue, you divide by Q, because Q is the number of products or units sold. So that is the same for basically your total revenue and your total cost if you need to work out the average. So I think that is important. Average revenue is total revenue divided by Q. Average cost is total cost divided by Q. So there's no, it's nearly a straightforward formula that you will need to use. And what they will do is they will tell you, so they need to give you certain information to get to it. So in this one, they said, okay, perfectly competitive firms' demand function is given by that. So again, remember, total revenue is equal to P times Q. Then average revenue is total revenue divided by Q. So actually what you are doing with that one is to get the average, you are dividing it by Q. So you're actually just cancelling the two Q's out. So your answer is P, and P was 20. So the average would also be 20. Okay, but this was a easy one because it was only that. If it was P is equal to minus 0.5 Q plus, then it becomes more difficult. But when it is that straightforward from the formula, it is nearly very simple to see that P times Q divided by Q, you're actually getting the P at the end again. But see, it's a bit more difficult when you're sitting with something like this. But again, if you just follow the same principle, because that is P, in total revenue, you're going to say again P times Q. If I don't give you Q, your average, again, you will divide by Q. So here you will see that your average will actually again be exactly the same. So your average revenue is actually the whole time price. So your price function will actually the whole time be your average revenue. It can be different for cost. So let's go to the cost function. And I think that is more nearly what we need to see. So interesting here, they tell you, okay, we are giving you the average cost function. So if I give you the average cost function, you need to remember that, and let's rather write it here, total cost was, and I can't even remember it now, where was that formula? Okay, so total cost divided by Q gives you the average cost. Total cost divided by Q gives you, so total cost divided by Q gives you the average cost. Okay, so to get the total cost, you will need to say average cost times Q. Okay, so then if that was your average cost function, you now need to say that times Q, that times Q, and that times Q. So let's see, 2Q times Q will give you 2Q to the power of 2. 5 times Q will give you 5Q. 30 times Q divided by Q will give you the 30. Okay, so if I give you the average cost, you will basically just need to multiply by the quantity to get your total cost. Okay, so I think last one to end of the day is here they give you a fixed cost, they give you a variable cost. So now we need to remember, okay, yes, total cost is equal to fixed cost plus variable cost. Okay, so let's do that first. So it is 30 times 2Q2 plus 5Q. Okay, so if I ask us to work out marginal cost, we would differentiate that. If they ask us to work out, but remember what we need to, wait, what did I do here? So it is fixed cost plus. So let me just, total cost is fixed cost plus the other one, not multiply. I nearly wanted to multiply. So if we want to do the marginal cost differentiation, so that will fall away. When we differentiate that, it will become 4Q, that will be 2 minus 1, so that will be fine, plus 5, so that will be your marginal cost. If we need to get to your average cost, we need to divide by Q. So now it will probably give me that. So it will be 30 divided by Q. So it's basically going back to what we started off there. 2Q to the power of 2 divided by Q will give me 2Q. And 5Q divided by Q will give me 5. So basically the average cost for this one was just again that one that we worked with previously. So basically what they could have done in the exam, they could give you the average cost. And from the average cost, they can expect you to work out the marginal cost. So then it is nearly, you need to remember, but again, they need to give you a bit of more information, because otherwise you are going to need to make assumptions in the total cost here that might be wrong. So they need to tell you part of the total cost is a fixed cost of that. But again, that could have been your fixed cost because it doesn't include a Q. That could have been your variable cost because both of it has a Q. So it's nearly, they can give you the average cost, and from there nearly want you to work out your marginal cost. Okay, so if that was your marginal cost that you needed to work out there, you could also see if you just did first derivative of that, it would have given you the 2 would have given you 4Q. like that, the 5Q would have given you the 5. So you could have actually, and there's now a lot of scribbling on this, but you can, from that point, you could have actually gone straight to your marginal cost curve as well, or function. Okay, I think we need to stop here, but let's just do a quick check-in. Does it make sense? I'll send this to the group now as well later tonight again, just that you can nearly recap. The recording will be on as well, so that is not a problem. So, but just nearly a sense check. Is it better that I do it this way, that it nearly sinks in and help you for preparing? So Eva, thank you. Yeah. The other guys, is it also okay? Okay, no. So I think that is, because that for me is nearly, it makes it then a bit simpler. Let's not say simpler, just a bit easier to understand, and just nearly brings everything together. Okay, so next time we will just continue with this, and I hope that we will probably be finished with this one, and then we can start with the integration as well. So let's see if we can finish this next week and then start integration as well. Okay, so have a good weekend, and then we will chat again next week. Let me just check if there was, let me just post the link again, but you can just complete attendance, and I don't know what else is in there, but just do that for me, please, and then I will stop the recording as well now, and then